Hello, good morning, good afternoon to everyone in our audience. Thank you for joining. I am your host for this session, Guillaume Calfon, supervising Middle East and Africa for Fluidtech. And it is my pleasure and my honor to introduce this recorded session by John Aramburu, who is OEM and key account manager at Atten. And Atten is a company expert in online fluids monitoring. And so the title of his session now is The Benefits of Online Solutions in Lubricant Lifecycle Monitoring, Focus on Asset Condition Management. And so this promises to be really interesting. And without further ado, let's get it started.
Hello, everyone, and welcome to the wonderful world of particle contamination and how can online monitoring help control it. Before we start, a huge thank you to the Lubrication and Reliability Virtual Summit team for allowing us to participate in this event. Also, congratulations to them for doing such an excellent job in organizing it. Okay, today we will be briefly discussing the benefits of online solutions in lubricant lifecycle monitoring, focusing specially on particle contamination. As we will see, lubricant contamination is one of the main causes of equipment failure, so it will be valuable to be able to control contaminants throughout the lubricant's lifetime. In today's chat, the idea is to give some background as to why the importance of oil cleanliness. Then we will take a look on how online monitoring can contribute to keeping the lubricant clean and within specs throughout its lifespan, beginning at the blending plant to the end of its useful life. For those of you who don't know me, which is probably all of you, my name is John Aramburu, and I am currently working at Atten Advanced Monitoring Technologies. I have an educational background in material science and metallurgical engineering, with some years experience in industrial lubrication, I'd say over 24. One note aside, looking at the panel of experts that are presenting throughout this event, I am humbled and must say that it is a privilege to be here and share this presentation with you. With this said, let's get started. I'm sure what I'm about to say is nothing new to you, but it's worth a quick mention. In this competitive world that we live in, it is important to constantly be looking to continuously improve in all areas within a company by finding ways to reach better financial results. Some of the most common concerns or areas to which we look at to have this continuous improvement could be safety, environmental impact, productivity, machine availability and reliability, total cost of ownership, quality, energy consumption, and so on. I'm sure I left some out, but you get the idea. It basically boils down to having a better HSSE, incrementing the overall equipment efficiency, machine reliability, and reducing the total cost of ownership. There are many actions in different areas that could be and are being taken to improve this. But today we will focus on only one. Okay? Although it may seem crazy, keeping an oil clean and as free of contaminants as possible could contribute to all of this that we mentioned. It's obvious that the industrial sector would not be investing so much time and money in filtration and avoiding contaminant entrance into lubricant for no reason at all. So, in order to work on improving all of these areas mentioned in the previous slide, we all know that a potent maintenance program can contribute in a substantial manner. This is why, to me, in my humble opinion, maintenance is an investment and not so much a cost. Of course, the more developed the maintenance program, the much better. As you all well know, there are different types of maintenance strategies, which would be considered depending on the criticality of the asset. It could be corrective for low criticality, to preventive, predictive for high, and proactive for very high criticality machinery. It is in these last two especially where you can see improved financial performance. Of course, the criticality is only a part of this, as there are other factors that need to be taken into account. With this said, it is also important to understand that within an excellent maintenance program, there is the need to have an excellent lubrication program. We are not just talking about lubricants, which of course are key, but we need to go further and establish a process to assure that the lubricant in use offers its optimal performance. Within this process, we could include root cause analysis. Some of the most common examples of root cause analysis will be particle, water, and air contamination, lubricant quality, not choosing an adequate lubricant, misalignment, design. These could lead to issues such as abnormal mechanical or corrosive wear, cavitation, microdieseling, which in turn could bring reduced lubricant and component life, higher filtration costs, higher energy costs, less machine availability, and most important, HSSE risks. So we can say that it is quite important to identify the potential failure mechanism in order to take actions to mitigate it. Also important, the earlier the root cause is identified, the better. Obviously, the objective is to avoid failure and non-program shutdowns, and in turn, shorten the program shutdowns. This way, we can establish those important savings that we were talking about. To help us achieve this, we will most likely need to invest in different projects. Budget and how quick we have the return is important to consider in this case. Online lube oil monitoring could be one of these projects or part of one of these projects to consider amongst others, of course. If we take a look at the pie chart, we can now understand why lubrication, friction, and wear are at the heart of machine reliability. 70% of machine failures are due to surface degradation. This is mechanical and corrosive wear. The 70% can be split up into 50% is mechanical wear, and which would be abrasive, adhesive, fatigue wear, and the other 20% due to corrosive wear. Also, if we take a look at the graph on the right, 82% of mechanical wear is due to contamination. Let's not forget that contamination is also the principal cause of lubricant deterioration and its subsequent performance drop. Scarier values can be seen below, where 6 to 7% of the gross domestic product is spent on fixing damage from mechanical wear. And if we add to this another 3.1% due to corrosive wear, we are actually talking about 1/10 that is spent on wear contamination issues. I'd say it is quite worth it to give some attention to keeping the oil clean and in optimal working conditions. This brings us to how clean is clean in an oil. As Einstein might say, it's all relative. It depends on how or from where you look at it. Anyway, and an established way of measuring this cleanliness is the norm ISO 4406. To briefly explain what it is, basically it is the count of number of particles in a milliliter of more than 4, more than 6, and more than 14 microns. Depending on this particle count, a number is assigned for a given range. Okay. For example, an ISO code of 16 would be between 320 and 640 particles per milliliter. As you can see, in each increasing number, we are talking about having the particle number doubling. So it's important to keep this in mind. Anyway, typical values of cleanliness for new oil could be around 18-16-13, 18-16-14, depending on the type of lubricant. Probably could be also 1 or 2 ranges higher, although there can also be oils which are considered the super clean oils as they go through an additional filtration process, and here they could be a couple of codes, ISO codes lower. Going back to the ISO codes to 18-16-13, if you really think about it, it's not really dirty oil. This value will represent half a teaspoon of dirt in a 208-liter drum or 55-gallon drum, which is practically nothing. Okay, The same thing happens with water contamination. 500 ppm is nothing. It's 100 milliliters. It's not even a third of a beer can. I mean, it's nothing. Okay, so it really does tell you how clean the oil really is, and how the process at the blending plant is quite good. But the unbelievable part is that it's not clean enough with some applications. For example, with some servo valves or journal bearings that require extremely clean oils. So you can see that with very little contamination, relatively speaking, of course, Einstein, you're the best, it would be very easy to increase the ISO cleanliness code, reaching alarming levels. Okay, so once again, it is safe to say that keeping an oil clean is not an easy job. Okay, here, to me, this is one of the most interesting slides that explains it quite well. We can see that in this table how the cleanness level, I believe in this case it's taken the 6 and the 14 micron values, how this influences in the lifetime of the asset. Depending on what type of application we have, this value could be different. Okay, for example, decreasing one ISO code, you could extend the lifetime of hydraulics of up to 30%. While for a gearbox, it would be 10%, which is still quite respectable. Okay. Then if you look at, for example, improvements of up to 5 ISO codes, when you have extremely dirty oil and with a good filtration, you could reach this. We are talking about 200 to 400%. This is unbelievable. Anyway, whatever value or application we're talking about, the benefits of having a cleaner oil can clearly be seen with this. So we can say this in another way. It's about taking care of our investments. We can purchase a new machine or asset, and the OEM gives us an indication that it could last, for example, 20 years. You can see how my friend is really happy. Oh, we're going to make a lot of money. He's like jumping in joy, right? Well, maybe. If we don't take care of it, it could last much less, influencing negatively in our financial results. If we take care of it, yeah, it could last just as long as expected, or even longer, which would be great. And it can happen. So, but okay, this reminds me, thinking about something else, that along the asset's lifetime, it's possible that modifications are made to the machinery to increase speeds, productivity, and so on. In this case, please check if any changes need to be made in the lubrication program in order to assure that the performance in the lifetime of the machinery will be respected. It's very important to redo the calculations if necessary. Okay, just have a note aside. Okay. Hopefully now we can see, after all this we've been talking about, why it is important to monitor particle contamination. By having as much valuable information as quickly and as early as possible, it should help to take actions to reduce failure and costs. Okay. Well, one option could be the integration of online monitoring technologies for real-time contamination detection. Here you could have a new perspective and maintenance as you're adding a new source of information in real time, okay, which help provide valuable time for planning and taking actions to reduce failures and costs. Also, as part of Industry 4.0, we can say that these new types of data are opening up strategies to increase lubrication efficiency. Okay. So obviously, the most important to have particle contamination control is at the asset itself. Okay, we're going back to the places where we could be installing this particle counters. Okay, but there are other areas where online particle monitoring could be useful. Okay, for example, actions taken throughout the lubricant's journey, starting at a blending plant, throughout the lubricant reception, storage, and lubricant dispensing to the machine. Then there are other applications such as offline filtration, flushing of individual and centralized systems, or as a complement to oil analysis. Okay. Concerning lubricant actions with fresh oil control, we know that as mentioned earlier in the presentation, some OEMs have very strict lubricant cleanliness requirements. As we've seen at the blending plant, new lubricant cleanliness is quite good, okay, but in some cases not good enough. Although, for some applications, some lubricant suppliers produce super clean products which involve an additional filtration process, okay. Cleanliness can vary from one product type to another, as we said before. With online monitoring, blending plant could have a quick and easy access to cleanliness data of all batches. I don't know if they're already doing this, or but anyway, this can be done. Okay. Although, then we go into the transport. During transport for bulk deliveries, the trucks are clean. I do know they do go through a product cleaning process and so on. But we know that with very little, the lubricant can be contaminated. So at the lubricant reception point, when unloading into the deposit, or especially into a centralized system, sometimes you are unloading into the turbine or whatever machinery itself. It could be interesting to have to be able to measure online the cleanliness. Okay. Also, even at the truck itself, this could be an option. Okay. Concerning storage. It could be interesting to have, obviously we're not going to have a particle counter in each drum that is stored in the warehouse, but it could be interesting to have a portable particle counter at the warehouse where there could be IBCs or drums or storage tanks that could be suspect to contamination. So you may want to analyze them before you dispense it into the machine. Okay. Now we get to the point that lubricant dispensing at the asset is most important, obviously. Okay. In this case, for example, a hydraulic and turbine oils normally require strict cleanliness levels. Okay. Online monitoring can be used to ensure specs are in accordance to OEM. And of course, let's not forget the main reasons we talked about in the beginning. Okay. About filtration actions. In this case, we could be talking about offline filters, where punctual interventions at a given moment in time are necessary, whether it is for solid particles, for water, for degradation byproducts. Here, online monitoring is valuable for knowing immediately not only what are the values to see how the lubricant is, but also if filter efficiency is correct, or if it needs to be changed, or if it could last longer. In this case, in this example, we have results of an example where there was a comparison of two wind turbine gearboxes. We are talking now at the process itself. They were both being monitored at the same time, and it was seen from the results that one of them, with the more efficient filter, had 20% less wear. Okay. On the left, we can see the individual results where on top, the one on top, the wind turbine is running a bit higher in cleanliness values. On the right, you can see the values are superimposed, so it is easier to see. Another area where online monitoring can be useful would be when you're performing flushing. Okay, you could have real-time results of cleanliness as the flushing process is performed. Okay, whether it is for the flushing oil itself, if used, of course, to see how much dirtier it is, or for the new or in-use oil to be incorporated. Okay, this helps obtain optimization and direct control of the process, and at the same time providing at the moment results to complement the lab results. Okay. To finish, we will be discussing some examples of life assessment of maintenance actions. Okay. In this slide, we are able to see with online monitoring technology when preventive maintenance actions were taken. Actions such as oil top-ups, filter changes. This is useful at first to know if and when maintenance actions have been taken and if they were able to achieve their goals. Okay. In this case, we can easily see the wear evolution in its 3 stages. How the wear rate goes from initial, which is normal wear, to slight wear, where wear particle double, and to severe wear, where we're up to 10 times increase. As we had mentioned earlier in the presentation, being able to detect wear rate in its early stages can bring important savings. Okay. Another example here is from a turbine where where a sensor was installed. There was a turbine trip incident, and the sensor was able to immediately detect a suddenly high increase of wear particles. As we know from before, having high quantities of particles in lubricant is a no-no, as these particles can in turn contribute to more wear formation. So, in this case, it was recommended to put a high efficiency kidney filter to decrease the quantity of particles to acceptable levels. Okay. This was an unexpected event, but it reminds me that online sensors are being useful to monitor startups at turbines also. Okay. Nowadays, it's normal to have turbines start up and stop often. We also know that it is when the turbines can suffer a bit. Okay, so it could be useful to have this monitoring here. Here, the example is concerning a wind turbine gearbox. Okay, the customer was already suspected and probably knew that there was something wrong with the gearbox. Okay, so in order to confirm this and to see also to see the sensor performance, a sensor was installed. Okay, based on two high impact events, it was seen that during the month of June, a considerable increase in particles was noted, and especially in very, very big particles. Okay, particle morphology analysis from the sensor showed how there was a considerable increase in sliding type particles, giving us an idea that it could be adhesive wear in relation with lubrication issues. Okay. Later, vibration results showed that there were issues in the shaft. Okay. A further boroscopic study revealed damage in both the high-speed and the low-speed shaft bearings. In 2 months' time, the gearbox was damaged and shut down for repair. Okay. This example, in this case, does not have to do directly with particles, but with oil degradation. Okay. This could be incorporated into the particle sensor. This monitorization of the lubricant degradation can give you real-time results of the examples top-ups. For example, variation of degradation in line with working conditions, which is useful information. Okay, and unexpected peaks that could give us clues as to possible contaminations of varnish formation. Okay, so we have come to the conclusions. I will read them as they are. So one of the conclusions will be keeping particle contamination under control is key for performance. The complete oil life cycle can be enhanced by the use of online lubricant monitoring, from fresh oil storage and delivery to the different maintenance actions. Okay. The application of innovative technology in lubrication services reduces operational risks and enables the possibility to create new and improved services aligned with the Industry 4.0 current trend, not only for the end user, but also for suppliers, where it could be a valuable addition, okay, to complement their service offer. Okay. And this is it. Thank you very much. I hope nobody fell asleep, and if they did, sweet dreams. Anyway, we are here to answer any questions that you may have. Thank you.
Hello. So,
Hello.
bring on the screen. Hello, John.
Hello.
So
Just beforehand, if I could just introduce our expert, which is Dr. Guillermo Miro. So he's also here if there's any questions. He will be here to help me.
Hello, everybody.
Hi. I didn't catch the name.
Guillermo.
Guillermo. Oh, I'm Guillaume.
Dr. Guillermo Miro.
We have a question for you two. It's on screen now. Can you see it?
Mm-hmm. Yes.
So I will read it. What parameters and specifications do you consider when purchasing an online device? as there might be several options on the market. I suppose it will be machine dependent, but
Yeah, very good
I'd love to
question
hear this.
from Juan. Thank you very much. I would say that the device you look for depends on the failure mode and your equipment and the failure mode that you are looking for, that you are looking to catch. Typical failure modes from contamination can come from different sources, in different actions, in different. So it's important that you understand which is the failure mode, because sensors will give you different information. So early detection of it, but also early detection in terms of when it happened. No? So if you are thinking about wrong oil top-ups with a degradation sensor, you will see a change in the oil degradation parameter, but also you will understand when it happened. So you even can trace up to the responsible of this oil top-up. No? But if it's a contamination with water, so maybe it can come from some dynamics from your equipment. So it depends on the failure mode that you want to catch and the equipment itself, for sure.
Now we have another question from Charles, and Charles is putting the finger on something I discussed beforehand a bit with John, which is what is the relationship? How will it affect online versus samples analysis?
Yes, well, basically, to our understanding, the sample analysis is all a very strict, very detailed type of analysis, which is done every so often. What this does, the way we tend to think about this is that the online sensor, the monitoring, is more as something complementary to the online analysis. Okay? So it's always good to have that early detection to say, okay, something could be going wrong, and it might be a good time to, let's say, send a sample to the lab to analyze, see if there's anything strange or something that shouldn't be there. We try to think about it as complementary to the.
I think your presentation was clear on the point that when you need immediate information, so during performing flushing, or if you have a suspected ongoing failure, then we can see why online brings more.
Exactly.
Another question from Kevin from Bahrain. Hi, Kevin.
Hi, Kevin.
Hello.
So you can see the question about moisture content.
Yeah.
Oh, okay. Well,
The measured water.
there are water measurements. There are sensors for that. In the market, you will find.
I would say that regarding moisture sensor, Atten has its own development on that based on near infrared technology. It's covering different ranges of existing sensors in the market, and it's available, but it's a different product from Oil. It's called Oil Health Pro Max. But we have moisture sensors.
And how well does it correlate with Carl Fisher?
Well, yeah. What it does, it measures. This is the sensor that has the option to measure in ppms. Okay. It does not, and then it will also measure if it's high water contents. It will change up to percentages. Okay.
It's a near infrared approach, so it will be similar to water content with FTIR. Same idea, no? You need a calibration curve to correlate with ppms.
Okay, all right. I think we are very near the end. We have less than 1 minute left. So, John, Guillermo, muchas gracias. I really enjoyed it.
Thank you very much. Thank you, everybody, for attending.
Thank you very much for putting up with me. So that's good.
My pleasure. What do you mean? Okay.
Okay. Bye.
Thank you.
Bye.
Great session. Thank you.
Thank you. Bye.